Hi folks, today we're going to discuss about the basics of Mapr and how Mapr has emerged into picture. So when the team from Mapr was trying to develop a solution, which was already existing, where we have hdfs. So Mapr guys were first looking at the limitations of HDFs and how can we overcome few limitations what HDFs has. So when HDF was developed, so they have foreseen few challenges and developed it, but still, so when they have developed it, they were in a hurry to develop and implement something. So basically, what I mean to say here is it's not to blame anybody. So the thing is, when you develop something new, it will have, obviously it will have limitations. So if it is a software, obviously software is bound to have bugs, so or any changes in the architecture or some flaws will be there. So but hdf was great at that time or now. It was in the sense we came out of the traditional way of storing and retrieving the data. So the traditional way was time consuming, so which HDFs has come into picture, and it has made our lives easier. So here what we're talking about is the limitations of HDFs before we see the Mapr architecture and stuff. So the limitations of HDFs is the HDFs obviously has two name nodes for redundancy, which stores the FS image and the edit logs. So basically, a single name node maintains metadata information for all the physical blocks that comprise the files. So when the physical blocks of a hard disk are creating the files, which which creates bottlenecks and impacts the performance for some extent. And and moreover, data in hdfs is immutable. For instance, if the source data changes, the data must be appended to the existing data or else reloaded into the cluster. For instance, here the same block size is used to define the IO size, sharding size, and the replication as well. So what I mean to say is, in the HDFs, the same block size, whether it is 64 MB or 128 MB or 256 MB, is used to define the IO size, sharding size, and the replication as well. So basically, we can see some kind of uh, one kind of inheritance being followed here. So this one size approach uh, doesn't explain the inheritance between these requirements. So this one size approach creates performance bottlenecks, and performance impacts. Apart from that, HDFS standard HDFS does not support POSIX file system semantics. It doesn't support POSIX semantics in the sense if you have data in some external storage or file system, you can't read it. So your data has to be first imported into HDFS via scoop job or something, and then it has to do the analysis. So even for accessing the data, you have to use hdfs commands. What I mean to say is, in order to read or write data, you should use the hdfs commands, and moreover, hdfs is limited support for snapshots or remote mirrors as well. So this snapshots and the remote mirrors are the main building blocks to enhance the availability and the usability of the data blocks. Okay. And And one more and one more drawback is, since HDFS is written in Java, it is comparatively it is slower than uh, file systems written and compiled in machine code languages like C or C++. So these are the few limitations which Mapr folks have taken into picture. So let me reiterate the limitations what they've considered. So here in the traditional HDFS, the same block size, the same block size is used to define the I/O size, sharding size, and the replications as well. And the second point is, it doesn't have support for standard POSIX file semantics. And the one more limitation is, it doesn't have support for snapshots or remote mirrors. And the next limitation is, as HDFS is written in Java, it is slower compared to the traditional machine code languages. It is more slower than machine code languages written in C or C++. So that's it for this session. If you guys like it, please like and share. If not, leave your comments so that I can improve myself. If there are any comments you guys give in terms of explanation or explanation and stuff. Thanks for watching this video.